two spacecraft caught the waves that might heat and accelerate the solar wind. Some lucky timing let the probes gather data that could explain long-standing solar riddles. A lucky alignment of two sun-studying spacecraft may have finally solved a decades-old solar mystery. Data from NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter suggest that plasma waves known as Alphen waves inject energy into the solar wind as it leaves the sun's outer atmosphere, potentially explaining why the solar wind is so much hotter and faster than heliophysicists expect. Researchers report August 29th in Science. The findings provide a very strong indication that Alphen waves can heat and accelerate the solar wind, says Jean Perez, a plasma physicist at the Florida Institute of Technology in Melbourne who was not involved in the study. Since the dawn of the space age, when robotic probes first left the atmosphere, scientists have known that the solar wind, a stream of charged particles released from the sun's atmosphere, accelerates as it blows out into the solar system. Theoretical calculations also indicate that the solar wind's temperature should drop as it expands into space. This drop does occur, but measurements find that it happens slower than predicted. Observations from Earth have previously spotted Alphen waves swaying near the sun. Such waves are oscillations in the magnetic fields of the plasma emerging from the sun. They are sometimes so large they turn back on themselves in what have been called switchbacks. The observed Alphen waves had the right amount of energy to explain the two long-standing head-scratchers about the solar wind's speed and temperature, but, direct evidence was still lacking. Enter Parker Solar Probe and Solar Orbiter. In late February 2022, Parker was passing through a region approximately 1/5 the distance between the Sun and Mercury, exactly where these switchbacking Alphen waves flutter. By chance, Solar Orbiter flew through the same plasma stream a little under 2 days later at roughly the orbit of Venus. You have these two spacecraft intercepting the same solar wind, allowing us to quantify the energy of these waves, says Jaime Rivera, a heliophysicist at the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts. Parker measured the plasma stream zipping by at roughly 1.4 million kilometers per hour, while Solar Orbiter found it to be tearing along at 1.8 million kilometers per hour. The plasma at Solar Orbiter was also a blazing 200,000 degrees Celsius, 3 times hotter than it should have been based on theoretical approximations. The Alphen waves had dissipated in the interim. This dissipation would have injected exactly the right amount of energy into the solar wind to account for the increased speed and temperature measured by Solar Orbiter, Rivera and her colleagues calculate. The effect is akin to flapping your hand in a wind tunnel, producing waves whose energy then gets mixed in with the surrounding air, says heliophysicist Sam Badman, also of the Center for Astrophysics. But not everybody is completely convinced that this mystery is solved. It's possible that the team did not account for the complexity of the solar wind, meaning that the two probes might not have intercepted the same plasma stream, some scientists say. Rivera and Badman agree that such measurements are difficult but feel they did multiple checks, such as finding the exact same amount of helium in the streams the spacecraft flew through to verify their observations. In the future, the researchers say they hope to further corroborate their findings by exploring the detailed physics behind the transfer of energy between the Alphen waves and the solar wind.